Okay, here's our video on radians with rotational speed. We're going to be talking about how we can calculate rotational speed with radians, and we'll talk about how to find the arc length. So let's get our pen ready, and we'll start with red. Why not? So if we had, and let's get a clear page. Let's get a clear page going. Let's just make sure we understand what we're talking about with these definitions. So the arc length, and let's get our pen. Like that there. So here we have the arc right here. This is the arc. And obviously we want to know the length of the arc. And sometimes it's denoted with this S. So that's the arc length. You can think of it as the crust of a pizza because this right here is a central angle. It's a central angle. Or it's a piece of pizza. Right? It's a slice of pizza, if you want to think of it that way. And this is the degree theta. They use theta, that Greek letter theta or theta, however you want to pronounce it. And so in this central angle, we have the center of the circle here. We have our radius, which is half the diameter. And we know this, right? And so this is 1 radian. And so we're going to be talking about radians in the circle. Okay. Now, of course, when you were in middle school and early high school, you learned about, when you first started learning about geometry, you learned about degrees, right? And so one radian is about, put the about here, it's about 57 degrees, roughly like that. So radians are much easier to use, especially when we want to get arc length and we want to get rotational speed, much easier to use. So that's why in high school you start using radians instead of degrees. So you have feet, for length, or you can have, meters, right? We can use the metric system. We can have Celsius and Fahrenheit and so forth. And we can have degrees and we can have radians. Okay, and here's a picture of 1 radian with the radius here. And of course, let's get our pen working there. This again is the arc length. So we'll just put S for the arc length. I'm going to show you a formula. So anyway, when you go from one point here, from this point here, and you go around the circle, and you go halfway, right? We know that's 180 degrees. But in radians, it would be pi radians. Something to remember. So if it's halfway is pi radians, then a complete circle, which we know is 360 degrees, would be 2 pi radians. That's important to know. So pi radians, of course, would be half the circle, and 2 pi would be the full circle. And here's a couple more. So you see that we had 1 pi over here. Now we have 2 pi. If we made a line, keep the green over there for a minute. So we had 1 pi. This would be one radian, and then this would be 2, and then this would be pi, as you can see it over here, pi radians. And here's 3 radians. So what you're not seeing, and I'll just put an arrow over here, the angle for that would be like this for 3 radians. And then you can see this circle here. So we have 180 degrees is pi radian over there. Let's go back. There's the pi radian over here. Let's go back. And you can see we have pi over 6, which is 1/6 pi radian. And of course, this would be 1/3, and so forth and so forth. But let's now look about how we can get the arc length. All right, and now I'm going to write a formula for you here. So if we want to get the arc length, and let's just make a central angle, we'll just say that is our central angle. This, of course, is the crust of the pizza. This is the arc, and we're trying to find the arc length, which we'll just say is S. And in here we have theta. Remember I said theta before? Theta is just that Greek letter, theta. It just means we have some kind of degree, or in this case, radian we're trying to find. And then we have our radius. So if we had 1, so instead of saying radius now, we just put the radius as 1. And we know that we have 1 radian. Put the 1 rad there, you'll see it. So again, we have 1 radian. The radius is 1. And we're saying this unit. We're just using units, whatever you're using, right? What is the arc length? Well, the formula is the arc length is going to equal whatever theta is times the radius. That's it. So in this case, we know that the radian, it's 1 radian times the radius of 1. So the arc length is 1 unit. So I'll do a few of these so you can understand them. Let's clear this out. Go back if you need to. All right, so let's make another central angle. All right, all they are is a slice of pizza. And I'm just oversimplifying here, so let's just say that this was 0.5 radians. And let's say the radius was 3. What is the arc length? How would you get the arc length? Why don't you pause and see if you can get that. So what is the arc length? What is the arc length? What is the crust of the pizza? Well, we know that S equals theta times radius. We know that theta is 0.5 radians, and we know the radius is 3. So the arc length would be 1.5 units, right? 1.5 units. Let's do a few more. Clear that out. Make another central angle. Again, I'm just making an oversimplification of the central angle. We're not saying it is actually that size and so forth, just for math purposes. So what if I had, what if the radius was still 3, but you got this, and you'll see this a lot, 1/6 pi radian. 1/6 pi radian. So again, just to understand something, try to make a circle here. We have our circle, and we know that half the circle is pi. So we would have to cut this up 6 times, right? So you have 1, 2, 3, 4, 5, 6. 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi, 5/6 pi, and 6/6 pi would just be pi, right? As pi. So we're saying this 1/6 pi. What would be the arc length? So, just plug it in your calculator, right? So you're going to say that the arc length is going to be 1/6 pi. Just plug that into the calculator. If you want to just estimate it, you can say 1/6 times 3.14. You'll get an estimate times 3. And so you're going to say the arc length is about 1.57 units. That's all we're doing. All right, let's do another one. Clear it out. Change the color. Why not? Make our slice of pizza the central angle. And let's say you had, let's say you had 0.2 radian. And let's say now you know the arc length is 5. How can you get the radius? So here we have the radian and we have the arc length. How can we get the radius? Well, just a little algebra, right? So we know that, again, the arc length is theta times the radius. We already know the arc length is 5. We already know theta is 0.2 radian. And then what do? We just divide the 0.2 on each side. So what did you get? I'll pause the tape, see what you get. All right, and so if you did that, we know that the radius now, not the radian, don't get them confused, the radius would be 25 units. Always think about the measurement that their teacher is giving you. Now, what if you didn't have the radians, that your teacher gave you degrees? So remember, it's very important that we remember that pi, when we use pi, it's 180 degrees, right? Because when we said that half the circle, we'll use another color, when we did half the circle, it was pi. And we know half a circle is 180 degrees, so we do have to convert. So let's say we had, and let's clear this out, clear it out. Again, we said that pi would be 180 degrees. And of course, we know that pi is 3.14, but when we're talking about radians, pi radians is 180 degrees. And again, half the circle, we have our pi. And if we went around a full circle, we would have 2 pi. So let's say we had 120 degrees. Well, we know 120 degrees, if we can convert it, we know that we're trying to find what it would be in pi. And we already know that pi is 180 degrees. So if you put it over 180 degrees, I'm giving you a little shortcut here. And do the math, we cut those zeros out. Now you have 12 over 18. Well, we know 12 over 18 is 6/9, and we know that 6/9 could be 2/3. Right? We're just reducing. So this would be 2/3 pi. 120 degrees would be 2/3 pi. And of course, mathematically, if you saw it, I'm just doing it very simple here. It's 120 degrees times pi over 180. That's how your math teacher might show it to you. And of course, you're just doing the same thing here. You're just reducing. You can also use, if you don't want to use a fraction, you can use a decimal. So what would be, if I change the color over here, use whatever that is, purple, violet, what would 60 degrees be? What would 60 degrees be in radians? 60 degrees. Let's say now you had this central angle, you had this slice of pizza, and they wanted to know the arc length. What is S? And all they gave you was the radius of 4, but 60 degrees. Well, if you find out what the radians are, you can find the arc length. So see if you can get the arc length by converting the degrees to radians. Pause the tape. All right. Change the color so we don't confuse ourselves here. So first we took 60 degrees, and we know that if we took 60 degrees over 180, and we know we would get 1/3, right? It's just 1/3 of pi. So it's 1/3 pi. And we know that the formula to get the arc length is the arc length equals theta, which is 1/3 pi, because we converted it, times the radius, which was 4. And so we would get about 4.18 units. So that's if we didn't have the radians, we had the degrees. Rewind if you need to. And again, one more. Let's clear that out. Clear it out over here. Let's say that you had, use green. Keep it as green. Let's say you had, it says 30 degrees. 30 degrees. And let's say you had, that was 4. Again, what would be S? What would be S? So again, S is going to equal, not 30 degrees, right? We want to convert 30 degrees into radians. Just put it over 180. You know that that's going to be 1/6 of a pi radian. So it's 1/6 pi radians times 4. And what would you get? So we have the arc length about 2.07. Should put that about sign over there. Man, what if we use the Earth? Well, the reason why we can't use the Earth is the Earth's not a perfect sphere. Sphere, not spear. Right? It's an oblate spheroid, right? So it, in a way, let's use red. When we're cutting it out, and we'll try to make a straight line over here, cutting through Middle East over there. And so the equator diameter is actually longer than the polar diameter. From pole to pole, it's actually shorter than the diameter from the equator. So, for example, this would be the diameter. We'll put a diameter over here. It would be about 7,926 miles. But the polar diameter from pole to pole is shorter. It's 7,899 miles. So you're looking at 27 miles more at the equator. So, the Earth has these bulges at the equator. So if we looked at, and let's just use the equator then, let's say that the radius then would be 3,963. And let's say we wanted to find a little sector of it. We have a little sector over here. We have our crust, a giant slice of pizza. This is our central angle. And let's say that we have our theta. Remember, theta is the degree, and it was 1/3 pi. What would be the central angle? What would be S? What would be the arc length? So again, S equals theta times R. S is going to be 1/3 pi times 3,963. And so we know that the arc length is going to be about 4,150 miles. Just using the Earth right there. Okay, and the last thing we'll talk about is rotational speed. Why don't we use the Earth? Just keep the Earth there. Why not? And let's use yellow. Right, so rotational speed. Yellow just comes right out in space. So if we look at rotational speed, we know that if we, again, we'll just use the Earth. Why not? We'll just cut this up in a quarter over here. And we'll have our central angle. And we know that if this was one unit, let's just say we'd use a unit, and we know that one unit is going to be 1 radian. And so 1 times 1 is 1. We know the arc length is 1. And because of that, because 1 radian equals 1 arc length, because 1 radian equals 1 arc length, we can get rotational speed. So let's give an example here. Let's clear this out. Let's go back to our circle and change the color. Use red again. Why not? So let's say this was a wheel. And we want to find the rotational speed of this wheel. And let's say they gave you that the radius of the wheel was 2 meters. So we have our diameter, and here's our radius now. We know it's 2 meters. And let's say that this wheel is turning. It's going this way. And it's turning at 6 radians per second. 6 radians per second. In other words, you can say it like this, meters per second, let's say. 6 radians per second, right? Well, I just wrote that, right? I'll say it again. Why not? And we know that it's, let's say that the speed, if we want to find the speed, all we have to do is just times the 6 radians per second by the radius. 6 times 2, which will give us 12 meters. Remember, we said here this was meters. 12 meters per second, right? And that's the slash means per. So that's all you're doing. You're just multiplying the radius times the amount of turns. These are the turns. Those are the turns. Let's say you had another circle. Trying to make a good circle here. All right, a little low pressure in the tire. And let's say that you already had the speed. Let's say the speed was 40 meters per second. So we already have the speed, and you have the turns. It's going 8 radians per second. Well, then what would be the radius? What would be the radius for this question? It's a little algebra, because we already know the answer is 40. That's the speed. And we know we're trying to find the turns, t. And we already know that it's going 8 turns per second. I mean, we already have the turns 8. And we're trying to find now the radius, r. Radius, r. So we just divide out the 8. And we know the radius must be 5. The radius has to be 5, because 8 times 5 is 40. So in our Next video, we're going to be talking more about radians. We're going to actually be talking about this is the arc, right? We're going to talk about the central angle, the area of the central angle, and more about radians. All right.